Okay, so where is the apex of this? Yeah. Right, very top. Exactly. Okay, how do I know it's a square-based pyramid?
Square.
Yeah, because the base is square. How would I know if it was a rectangular-based pyramid? Oh, I don't know. Maybe the base would be a rectangle? Yes. Okay. I know that the height is always the perpendicular height straight down from the apex, which means the slant height goes where? It's the height along the triangular face. So this right here would be the slant height. Okay, so this one's the perpendicular height, right from here to here, perpendicular height, and the slant height is out along the triangular face. Make sure you have all those things. Pretty good on that? All right, so if you're good on that, we're going to move on to the first example, and I messed up. It actually says it's on the bottom, but it's on the back. Okay, so flip it over. What I would like you to do is start trying to find the surface area of this this square-based pyramid. Okay? So when I look at these, just stop for a sec and look up here. We know that the slant height goes on the side, and there might be a few different types of pyramid that you're going to see. So a regular tetrahedron has 4 triangular sides. So you would just find the surface area of one of those triangular sides and multiply by 4. This one's a right square pyramid, which we've seen. This one's a right pentagonal pyramid, which we won't be solving unless you want a little bit of a challenge. But these could all be classified under pyramids, okay? All right, so this one has a slant height of 10 centimeters. It also has a base length of 8 centimeters. Where do you think I can start on this one? Yeah. Sorry? You could start by solving one of the triangles, sure. So if you look at your data pages, it will have all of the formulas that you need for each of the shapes that you will encounter. So you will find the formula of a triangle, you will find the formula for a square and a rectangle. You'll also find the surface area of a rectangular pyramid and square-based pyramid as well, okay? So if I was to go ahead and try and find the area of this triangle, I know that the base along here is going to be 8, and the height of the triangle, which happens to be the slant height, is what? 10. So if I'm using that in my area of the triangle, I've got base times height divided by 2, and that ends up equaling 40. How many of those do I have though? 4 of them. So I'm going to multiply that by 4. So I've taken care of this face, this face, this face, and this face. What if I was given the actual height inside the triangle? Could I use that? Sorry? Okay, so how could I use the regular height to get the slant height for this rectangular pyramid?
Oh, using it as like the triangle.
Yeah. What did I just create inside here? A right angle triangle, okay? So you can use the Pythagorean theorem in order to get this if I had to. We'll do that in the next question.
Wouldn't that be 4 by...
Yeah, I don't actually know what the height is, so I can't do it yet. Yep. Okay, what else do I need to figure out? So the base, right? How do I find the area of the base? Okay, it's going to be 8 times 8, which is going to give you 64. So at the end, if you add up 160 and 64 from the base, you're going to end up with 224. If you want to move here, or you can be here, or you can see him here? Okay. Yep.
But at the end, it's a surface area, it says 2 times base times plus like the base of the tower.
Yeah.
Yeah, I was just dividing.
Okay, but if you divide something by 2 and then multiply it by 4, what happens? It's the same as multiplying by 2. Okay? So everybody take a second and look at their formula sheet. What is the formula for finding the surface area of a square base pyramid? Yeah?
I hope I'm right. This is for a square base.
Square base pyramid?
Is it? I wrote down as 2 plus base squared.
Yeah. That's it. That's it. And does this make sense? Base times slant height divided by 2 times 4 is the same as multiplying by 2. And then what does this represent? The bottom part. Okay, so this is exactly what we just used. This is the formula you're going to use from now on.
Wait, is there nowhere like big B and little b?
So if you're talking about the area of the base, that's going to be big B. So if I said, what is this whole thing, it would be big B. If you were calculating it, it would be little b times little b. Okay, so we'll talk about that a little bit more when we get there. Alrighty, so let's move on to one that's a little bit more difficult. Not that one. This one's example 2 on your page.
Why are you recording this?
Sorry?
Are you recording this?
Because some people aren't here, and I want to post it just so you know. Okay, so it says a right rectangular pyramid has base dimensions 8 feet by 10 feet and a height of 16 feet. So now it's no longer a square base pyramid, it's a rectangular base pyramid. So take a second and try and draw a rectangular base pyramid. Do your best because it will really help you understand.
Sweet, I did a question.
So a rectangular base pyramid. So usually you should start with, you can actually draw it on the next page, I left a bunch of room. Usually start by drawing a nice triangle in the front. And then going back from that. And this is where it gets a little bit more complicated. So now I have to use the Pythagorean theorem a couple of times because I no longer have the slant height.
That's pretty.
Okay, let's see how you guys, yeah, that's good. So put your dimensions in. That's actually pretty good. Yeah, you can actually put it on the next page. I messed it all up. So for some reason I put this, I don't know. Yeah. Yeah, that's a rectangular base pyramid. So it's the same idea as a square base pyramid, but the bottom is just a little bit longer. Yeah, it is a little bit too pronounced. So try and
You suck.
put it down a little bit more. Okay.
Why don't you show us some examples?
No. That's the whole idea that you can learn. So start with the front triangle. We'll draw back from that.
We'll have fun drawing through it.
Okay, that's not bad. So then, this will be your height. It's always going to be different. You're 16 feet. Then you can
Have fun drawing through it. Okay.
Okay. That's going to be hard to label, but that's okay. So draw the first triangle. Yeah, you got it. Yours is a little bit bigger.
Do it.
Okay, that's fair enough. Yeah, yeah. Alrighty, so now you've got the 10 feet along here. You've got the 8 feet along here. And the key thing is that you have your height in the middle, so it's going to be perpendicular. It is not the same as the slant height. So if I was going to start with this, I would start by finding the area of the base. Okay, so I'm going to write area of the base. So you can do it on your own page while I'm getting this one. So what's the area of the base in that one?
8 by
Yeah, you can answer.
okay.
It is
80.
8 by 10, exactly. So it's going to be 80 feet squared. I don't know what they're doing in that room, but they're shaking the whole thing.
Leave all the heads down.
Okay, so we found the area of the base, and that's 80 feet. Now I have to find the area. Now I have to find the area of the triangular faces. So if I start to find it using these measurements, things start to become complicated quite quickly. And this is where you have to keep track of what you've done and where you are in your solution. So if I choose this triangle to start with, so you choose the one with the 8 as its base, okay? That's, for me, is the front and back triangles. For you, it might be the left and right side. What is the base of that triangle? What's the base of this triangle? 8 feet. What's the slant height of this? What's the slant height out front of this triangle?
You want to figure it out or do you want us to?
Do you know it? No, you don't. So now I have to find the slant height for this triangle. And I'm going to call that S1. The way we're going to do that is using the Pythagorean theorem. So basically what I've done is I've got a 3D model here. I've got this one as a hypotenuse. I've got this extending back into the triangle so it meets the height head on. And then I've got this as the back side of my right triangle. So what I'm going to do is pull this little right triangle right out and try and solve for it, okay? So it's confusing at first, but you'll get it. So here's my right triangle. If I look at this, what is that? It's the height of the triangle, so it's 16. How long is it down here? Okay, it's 5. How did you get 5? Because it's half 10, so it's half of all the way across here is 5, so I'm going to use that on the bottom. This is the slant height of this one, so I'm going to use the Pythagorean theorem to solve for that. This is as complicated as these questions get. So we're jumping right into a complicated one. You can see it right off the bat. So this one says S1 for just the first slant height I'm trying to find. So it's going to be 2. All right, do I know how to solve triangles like that? Yes, I do, so let's do that. So I'm going to go 16 squared plus 5 squared. Figure out what that is. If I take a square root of that, I'm going to end up with 16.76. And in this case, I really want to keep as many decimal places as possible. Okay, so now I know that the slant height for this one, so out front here, is actually 16.76. Do you see where that is? Yep. Yeah.
On the calculator.
Yep.
Those two square root.
Struggling with that square root. What?
Well, I'll put the square root side over the different, and it's just giving me the exact same as the square root side.
Okay, I'll be there in 1 second.
Okay.
All right, so now that you know the slant height for this, can you find the area of the triangle?
Yep.
Okay, so do that right now, please. So base times height divided by 2. Oh. Oh, big. Oh, you're in math print, or do you want to be in class?
There we go.
Okay, so your area of this triangle is going to be the base, which is 8 feet, times the slant height of this one, which is 16.76. I'm going to divide by 2 because that's part of the formula, but then I'm going to multiply by 2y. This is one of my triangles. How many more do I have? 2, right? So front and back. So I'm going to divide by 2. That's part of the formula. Then I'm going to multiply by 2 because there is 2 of them. When I do that, I will end up with 134.1 feet squared. So now I found the front and back. I found the base. Which ones do I have left to do? Okay, so we've done the front and back, the base. Which one do I have left to do? The sides, the left and right side. Or if you drew it differently, it might be the front and back. Okay, so what I want you to do is try that one on your own. I'm going to come around and help you. Just keep in mind, now you're trying to find the slant height over here. So you've got a different section that you're doing. So let's put that on a new page. Sorry? It's exactly the same process, just for the other side. Okay, don't just quit. Do it on your own. Come on, guys. I ate on those others. Okay, so now I'm trying to find the slant height of this triangle over here. Yeah, it is. Yeah. Okay, so now for this triangle, I've got the regular height inside, which was 16. I'm going to create my little right angle triangle up here. So this down here, 16. This is the bottom of my little triangle, and I'm trying to find the slant height out here. So I'm going to call that S2. Here's my little triangle. It's coming from here. I don't know what the slant height is. What is the bottom of my triangle here? 4. Because it was all the way across was 8. So halfway across is going to be 4. And then I know the height was 16. That was this guy. Now I'm going to go through the process of 4 squared plus 16 squared equals S2 squared. Hey, don't get discouraged. I know this is complicated. It's okay. You will eventually get there. So if you take the square root of that, you end up with the slant height as 16.49. So I'm going to keep the 49 in there to be as accurate as possible.
2.
Okay, or 492. Am I done? Okay, so I'm not done. All I've found is the slant height here. Now I have to go back and figure out what is the area for the left and the right triangles. So I know the base is 10. I know the slant height of this triangle right here is 16.49. So I'm going to go base times height divided by 2. And then multiply by 2 again, because there's left and right. So I'm going to have 10 times 16.49 divided by 2 times 2. And that's going to end up equaling 164.9 feet squared. Are you done? Okay, you just keep going. You don't have to wait for me. So divided by 2 was part of the base times height divided by 2 is the formula for a triangle. But then there's 2 of them, so left and right, so I just multiplied by 2. So that actually goes away.
Okay. Is it okay if you differ by I got the exact same thing?
Yeah.
Sorry, I did the exact same thing.
Yep.
But I got an answer that was 7.63.
Let me just check. Okay, so 164.9 plus, where am I starting to add now? Okay, so I'm adding all the sides together. So this is the base, this is left and right. What about the front and back? I don't remember what that was for. 134? And what does that all add up to? Okay, and some decimals. If you got something really close to that, that's okay. Sorry? There is some decimals. Okay. So if you got something close to this, that's great. Try and get as close as possible by keeping as many decimals as possible. Okay, that's pretty complicated, but you can do it. It has all the skills that you used before, Pythagorean theorem, finding areas of triangles and squares and rectangles and just putting them together now. So what I want you to do is for the formula at the bottom of this page, there isn't one that's going to work for all of them. So I want you to write on there, find the area of the base. So at the formula on the bottom of the page, write find the area of the base. Then find the areas of the left and right triangle. The areas of the front and back triangles. So area of left and right triangles. Area of front and back triangles. Area of base. And then add all together. And you might have to use the Pythagorean theorem. Alrighty. Okay, that's where we're going to stop. I'm going to ask you guys to try the question on the page. Okay, I'm going to ask you to try the question on page 29, and it's check your understanding number 2. Check your understanding number 2, page 29.